Greetings and welcome, friends. Mr. Wada here. Today we are talking about solving polynomial equations in factored form and going over some of the homework real quick. And notice, my friends, that this appears to be two things. They're weird-looking things, but they multiply to be 0. And according to the zero product property, let's see, Kayla, I just drew your card. I don't know if you're ready for this. But what do you think could be true about these two things that multiply to be 0? What do you think is going to happen? I can break this up into two cases. Okay. And either s minus 9 is going to do what? Equal. Okay, so either s minus 9 equals 0 or s minus 1 equals 0. And the reason that's true is I've got two things here that multiply to be 0, so therefore one of them must be 0. And now I just solve these normally. Let's see, Tyler, how could I get s minus 9 equals 0? How do I solve that for s? Yeah, add 9 to both sides. All right, so s equals 9, and we are time traveling, which even if we're not traveling faster than normal time, we are always traveling through time. I don't know if you realize that, at a speed factor of 1. True story, true story. So to solve this for s, add 1 to both sides, and s equals 1. And this was the 381 homework, question 7. So here we go. So that's how you solve these when they're factored. Factored means when it's written as the product of things. Okay, so let's look at this other one. Same idea, a little bit trickier. Austin, what do you think I could do here? I've got two things that multiply to be 0. So I break it up into two cases. And what are those cases, Austin? Or... I like it. Let's see. Can someone help me? Brandon, could you help me solve this one for A? How could I get A by itself? I could, actually. And in this case, it actually wouldn't be too painful. Yeah, normally we reverse PEMDAS these, where I'm going to deal with subtraction before the multiplication. Division, though, in this case, wouldn't have created fractions because 6 is divisible by 2 as well. But, well, let's find out. Yeah, this one's definitely going to have a decimal over there. So I'm going to have 2a equals 6. And now, Austin, I'm going to divide by 2. You're not wrong, by the way, for dividing by 2 first. Most of the time, that will end up resulting in a lot of fraction work for you as you go through it. Micaiah, would you be able to help us go through this half of the problem? I like it. Subtract 15 from both sides. That's going to cancel out with that. I'd be left with 3a. Line up my equal signs. Line them up. Negative 15. Oh, wait. I just told you it was going to be a fraction. You know, I was wrong. I forgot this next step will work out. So, Micaiah, what do you think? How do I get a by itself? It's being multiplied by 3. Yeah, so the inverse operation would be a division, and I'm going to have a equals negative 5. Kayla, did you spot where your fraction might have showed up from, or? I don't know. I ended up not having a fraction. I thought there was going to be one. That definitely would have been the case. Yep. Okay. Let's see. Next problem. Factor out the polynomial. All right. So this was called greatest common factor. I like to think of it as like a reverse distribution. And this is when I'm going to steal from every term possible. And I'll go a-hey yoink and a-hey yoink. And between 3 and 9, Brandon, what do you think is the biggest number I could steal from that? Between 3 and 9. What's the most that both of them can afford? Is 3. Yeah, 3 goes into 3 as well as 9. And between y cubed and... Oh, like the difference? Ah, yes. Let's see, here I can steal a y squared. I can only steal what the poorest one can afford, right? Y cubed has enough y's for a y squared, but y squared can only afford y squared, so I can't take out more than that. So when I factor this, right, through GCF, I'm undistributing, so I'm going to write 3y squared on the outside of a set of parentheses. And now my question is, what would have gone here? So 3y squared times what would equal 3y cubed? Now 3 times 1 would have given me 3, and y squared times what would have given me y cubed? Ooh, no, I disagree. So y squared times blank equals y cubed. 1y, yeah, yep, or y to the first, right, because 2 plus 1 will equal 3. Yeah, I don't need to write the 1 in front or the exponent there because they're implied when I don't write them. All right, let's see. 3y squared times what would equal negative 9y squared? 3 times what is negative 9? Negative 3. And y squared times, oh, I already have a y squared here, so just times 1 or whatever. So y minus 3 is what's left in parentheses. This is now factored, where I've written this binomial as the product of polynomials here. And that's... Yeah, those aren't like terms, so I can't combine them. Maybe you... Oh, you must have multiplied. Okay, good question, Brandon. This cubed only applies to the y. When we were doing the special patterns, remember back when we'd have to put parentheses around it? If there's parentheses around it, then the exponent would have applied to the 3 as well, but it doesn't in this case. All right, last question. All right, I'm going to do this one for us. I should put my own name on a card and draw it sometimes. That'd be pretty good. It says, solve the equation. Now, I can't solve by just subtracting 25c from both sides and dividing by 10, etc. What I'd need to do is write this polynomial in factored form. Actually, the first thing I'm going to do, I'm just going to rearrange this to write it in what's called standard form, right? Remember standard form, highest exponent to lowest exponent. And now I'm going to factor it using the yoink method, where I'm stealing the biggest thing I can that each of these terms can afford. So between 10 and 25, what's the biggest number that goes into both of them? 10 fits into 10 evenly, but it doesn't divide into... Yeah, so it's going to be 5. And between c squared and c to the first, how many c's can I steal that each of those could afford? Oh, just plain old c to the first. Because this guy can't afford to, lend out a c to the second. He doesn't have it. All he's got is 1c. All right, so 5c, I'm going to write on the outside of a set of parentheses, equals 0. And on the inside, I could ask the question, 5c times what would equal that? I can also ask that in reverse and say 10 divided by 5 is 2. Right, so there's a couple ways you can think about that. 5 times what is 10, or 10 divided by 5 is what? And c squared divided by c happens to be c. We haven't talked about dividing like that. Yeah, just a minute. And 5 times what is 25? Well, 5 times 5 is 25. Yep. And then c times 1 is c, so I don't need to have any more there. Now that I've got this written as the product of things, I've factored it, I've unfoiled it, foiled it, although this was actually not foiled to begin with, because foiling is only a binomial times a binomial. However, now that I've got two things that multiply to be 0, I'm going to use my first skill, the zero product property from yesterday. Let's see if I can get a better line. There we go. I like that arrow better. So I break it up into two cases. Either the 5c was equal to 0, or the 2c plus 5 was equal to 0. And now I just solve both of these normal style. Normal style. So c is equal to 0 divided by 5, which is 0. Or over here, subtract 5, subtract 5. I get, this one's going to be a fraction. I can see it coming now. Here we go. Divide both sides by dose. And I get two answers here. C is equal to 0 and C is equal to -5 halves. And if I did a check where I plugged this in for both C's in the original problem, it would work out. I'm not going to take the time to do that right now. Thanks for watching. Bye-bye.